Okay friends, so let us start another topic here, that is Coulomb's law. Okay, Coulomb's law. This is an important law in electrostatics, and it's very similar to Newton's law that you got in gravitation. Here, suppose we have two charges. One is say your Q1 point charge, okay, another is your say Q2. These two are your point charges. Suppose both are positive, say maybe positive, maybe negative, no problem, but we are taking here positive charges, Q1 and Q2. Suppose they are separated by a distance, say it is R. The distance of separation between the two charges is R. The charges are Q1 and Q2. Then Coulomb's law states that the force of attraction or repulsion between the two charges is directly proportional to the product of the two charges, and this force is inversely proportional to the square of the distance between the 2 point charges. Okay, so if I combine these two, I'll get F proportional Q1 Q2 by R square. So F will be equal to, say any constant, it is K Q1 Q2 by R square. Now this constant K can have a value where K equal to 1 by 4 pi epsilon naught, where epsilon naught is a permittivity of free space. So I can write F will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, then value of this K in SI unit is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. And this permittivity of free space, epsilon naught, value of epsilon naught will be equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. So this is the Coulomb's law in mathematical form. You can say F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where Q1 and Q2 are two point charges, okay, and R is the distance between the two charges as we discussed here. Now you can also this one define your Coulomb's law in vector form, and you can also define 1 Coulomb charge from this Coulomb's law. Let us first define 1 Coulomb charge. Okay, 1 Coulomb charge. How we can define 1 Coulomb charge from here? See, it's very simple. If you take this equation, okay, and in this equation, suppose if Q1 equal to Q2 equal to, say any value, just I am taking here, if Q1 equal to Q2 equal to 1 Coulomb, and R, that is the distance, R equal to 1 meter, I am taking the SI value, then from here F will be equal to what? F will be equal to 1 by 4 pi epsilon naught. Okay, because Q1 is 1, Q2 is 1, and R also 1, so this will become only 1. So F equal to 1 by 4 pi epsilon naught. What is the value of 1 by 4 pi epsilon naught? You know very well from there. You are finding now the force. This much into 1. Of course, this much into 1. Units will be here, of course. If you put the value of Q1 and Q2 here, 1 Coulomb into 1 Coulomb. So this will be, of course, here Coulomb square divided by meter square with this. It's not it. If I put the value, I will get here. So now this 1 by 4 pi epsilon naught coulomb square per meter square, when we are putting this value of 1 by 4 pi epsilon naught, then we will get it here 9 into 10 to the power 9 Newton meter square or coulomb square into this one, coulomb square by meter square. So ultimately we are going to get F will be equal to 9 into 10 to the power 9 Newton. So how one can define 1 coulomb? That is that was our actual point. So how we can define now? 1 coulomb is that amount of charge that repels an equal and similar charge with a force of 9 into 10 to the power 9 Newton when placed in vacuum at a distance of 1 meter from. Suppose you have two charges, one here and one there. You don't know the value of these two charges. You don't know the value, but they are separated at a distance of 1 meter from each other. Okay, these two charges. Say any two charge I am taking here, and now they are experiencing a force of this much, 9 into 10 to the power 9 Newton, when they are separated by a distance of 1 meter in vacuum. If it is so that two charges are placed in vacuum at a distance of 1 meter from each other and two charges are similar, similar means magnitudes are maybe same, then what are the two values of the two charges? That will be basically 1 coulomb each. Okay, so very simple. You can now define 1 coulomb charge. Anybody can define now 1 coulomb charge. What is 1 coulomb charge? What I told just now, that 1 coulomb is that amount of charge that repels an equal and similar charge with a force of 9 into 10 to the power 9 Newton when placed at a distance of 1 meter from each other in vacuum. Okay, so this is how we can define 1 coulomb charge, and of course its definition is given in my notes. You can note down from there, no problem. Okay.